Okay, hello. Welcome to the we're still in April meetup of the AI Enterprise AI virtual user group. And just to make sure that everybody can hear us and see us, please use those emojis at the center, bottom of the screen, just to give me feedback that everything is fine. And during the talk, please. Okay, I see the responses. Great. I see something on the chat already. Okay, can hear loud and clear. Great. So use the chat, use the question and answer. You use the emojis whenever you feel like. We have Leonardo Moraes. Moraes, I'm not sure I'm pronouncing it correctly.
Yes.
That you look really young, and they didn't believe that you could be a professor and understand a lot about AI. I'm just kidding. They just said you look really young. So I guess it's a compliment. So we have Leonardo here to talk about AI in games and gaming, which is a very exciting subject. I know nothing about it, so I'm very excited to hear about it myself. So I'm going to leave the stage to you in a second, and you can get started.
Okay, thank you. I'll move you for this screen. So sometimes I will look for that screen. Sorry about that, because I shared this screen. Let me share my screen. Actually, I look younger because I use an artificial intelligence to look younger. So that's my secret. I'm joking. Okay. Okay. So first of all, thank you a lot, Eyal, Manny, and you guys for being here. You've made notes, but I'm not American, at least not from North America, so I have some difficulty to express myself in English. So expect some English issues during the presentation. Sorry about that. But I also would like to remember that I expect from this presentation be introduced from artificial intelligence. I will just bring some highlight talks and the games itself. And today I will talk some study case that I developed with a game called Super Mario Maker. And I hope you enjoy. And I won't share any code during this presentation, so only slides and animation. But all the codes are public available, and I will provide the links later. Okay. So the title of the presentation is Introduction to Artificial Intelligence Applying Games. Let's pass through the most boring part quickly. So I am Leo Moraes. I am machine learning engineer. I also work as a professor and tutor in some companies. I work as a tutor in a university, and I work as a professor in a digital school. And this year, I just started my PhD. So right now, I'm PhD candidate as well, working, of course, in artificial intelligence. For who don't know, this is an artificial intelligence presentation. I just put here just to remember you guys. First of all, I will pass by an introduction. So what is the universe of the games? What are the games? What do you have inside of the games? I will briefly do an AI introduction just to a few AI terms, because it's always interesting to remember them. Later, I will talk about data sets. So to work with artificial intelligence, not to work with artificial intelligence, but to do some artificial intelligence projects, some of projects, we need data. So I bring some data repositories that you can use to work with artificial intelligence, and a data repository of data data from games. So where you can a place to you to use data from games or whatever. It's different data sets from different games. I'll explain better later. um, in the end, I will finish with the case study that is the Super Mario Maker project that I developed. And this is interesting to say that this was a part of my master's degree. So uh, master degrees is a little different around the world, but here I'm from Brazil, so here in Brazil, the master degrees it's a kind of similar to a PhD, a small PhD program in United States, where you have to develop some theoretical thing and do an application just to evaluate the theoretical part. So I will pass by a theoretical. Of course, I won't detail any any mathematical thing here, just to show some plots and explain how they works. It's more it's better to see the plots. But if you are interested in the code as well, I can provide for you. Actually, it has the links in the presentation. Okay, so introduction. Um, Today I will talk about digital games. You can understand games as any kind of entertainment. For example, two kids discussing or playing, imagining that are, I don't know, warriors. It's a kind of games. But when I talk about digital games, are games developed for a digital device or electronic device. So I mean, mobile cell phone, a computer, um, specific devices like a game console. It is a PlayStation or Xbox, so on. So this presentation focuses on digital games. And why I focus on digital games? According to Newzoo, a company specialist in marketing analysis, gaming marketing, digital games are the most popular form of entertainment in the world, reaching millions of players. So it has a lot of people. The universe of the game, so it's not only the game, but everything that it's around the game, it's constant ascendance, both in production and consumption. Just to to know a little bit about uh, the estimated revenue of 2021 was around 189 billion of dollars. It's a lot of money. So it's a it's a place that you can find a lot of money. So it's heaven. So yeah, it's a lot of money. And also I choose digital games because it's cool. I like games, so work with games it's easier, at least for me, for learning. Oh, and games is also interesting because it's a place where you can uh, quickly apply an artificial intelligence algorithm and see the results. So you can really see the results, what's happening in the game. So there are the motivations. I hope that is a huge motivation. We can see the revenue motivation, and it's cool. I am a little nervous. Sorry about that. Okay, but as I mentioned, the games, the universe of games, is not only the game itself. It has a lot of another things too. For example, we can see the esports. It's a kind of esports means electronic sports. It's a competition of professional players. So we have professional players that compete against each other in some selection of in some selected pre-select games, and it's increasing the importance of the esports, and the people are thinking enjoying the esports in Olympics as well. So just to see how the digital games are important in the news area. We have another kind of players too that are called streamers. Usually, streamers are gamers that produce online videos or online content in general, but streamers are more for online videos. And just to have an idea, the audience reached around 728 million in 2021. So it's a lot of people watching the streamers. And this is growing year after year. So from 2022 to 21, increased 10%, but year it's around 90%. Also, this was said by a news. Um, and these guys, so the professional players and the streamers, are called game influencers. Game influencers is a kind of digital influencers for games. It's easy. It is game influencers. So, o game influencers exist since the popularization of social media. So, the web 2.0, where the people start to share content and start to share content about games. And these game influencers produce online content in general. It could be online videos, the streamers. It could be only be blog posts, or forums, and so on. But in somehow they are called digital influencers of games or game influence because they have some influence in other people. So everyone that is called digital influence has an influence in new trends. So imagine that I am a game influencer and I am playing, I don't know, Super Mario Maker. And everyone who watch me see, oh, I am using this game chair, I use this game keyboard, and so in somehow I am producing marketing for the products that that I'm using that are. So the people who watch me uh, start to become interested in my content too. So this is the rule of digital influence. In somehow, they influence people to use his or her products. And of course, the gaming influencers do the same for computer devices, for gamers, or so on. Okay, so now you got a general idea what the universe of games are. I will briefly say some artificial concepts just to maintain everyone the same level. We do have a lot of terms in artificial intelligence. I just bring some of them because they are basically the most important ones. We have a big area, a big area called artificial intelligence, and this area it's kind of generic. You can, according to Russo, that was uh, a big researcher in the artificial intelligence area. Artificial intelligence is an intelligence demonstrated by machines. And somehow the device, the machine, perceives its environment and taking some action according to it. So let's imagine I am in my room and I have a light sensor that detects how many light it has outside of my room. So it is dark outside or it has sunlight. So if it has sunlight, they automatically turn off my lights because I have sunlight. I don't need the artificial light. But when it's become dark, comes to evening, they turn on my light. So this device, this machine, is capable to persist to understand its environment to see if it has light or it's darkened, and take an action according to each. So turn on or turn off the lights. So you can see that it's not too intelligent. Doesn't matter how many intelligence it is. The importance is that it take an intelligence action according to its environments. So everything that it has some intelligence, doesn't matter how much intelligence is, it's an artificial intelligence. It's a kind of an artificial intelligence algorithm. And in this my case, a simple automation. I just see how much of light my sensor of light says that it has light outside, and turn on or turn off my lights. Okay, so in this huge area, we have another area called data mining. Data mining, according to Han and Campbell, data mining is an area that is responsible for extracting knowledge or discover patterns into data. So we have to oh my god, I forgot the word. We have to, oh my god, we need data to discover the patterns. We need data to make some prediction, for example. So to do data mining, we need data. And as I said before, to do artificial intelligence, in some case, we don't need data. So my device that turn off and turn on my lights doesn't need data. I just need to create an if-else structure that says, oh, if it's dark, turn on. If it has light, turn off. So it doesn't need data to learn everything. But in data mining, specifically in data mining area, we need data to do the mining, to extract knowledge, to discover patterns in this data. Okay. So let's deep dive. Inside of data mining, we have an area called machine learning. Actually, the term data mining is dying. I saw most people only saying machine learning, but data mining involves databases, data warehouses, statistics, simple statistics, and machine learning. So data mining involves three big areas. But usually I saw people only saying machine learning instead of data mining. And when I say machine learning, I'm thinking in algorithms or techniques that are able to learn through the experience or through the data. So they receive the data and discovers the patterns or discover a grouping, discovers something automatically alone. Of course, they need the data scientist or the machine learning engineer to make some adjustments, but the general definition is that machine learning are algorithms that are able to learn alone, that are able to learn automatically. And inside of the machine learning, we have the deep learning, that is the breakthrough area that we have right now, that are machine learning algorithms that are able to reach high accuracy, high precision, or high whatever. Basically, they are a kind of technique of machine learning. They are not so young. They are pretty old. Deep learning, the first deep learning algorithm was developed in 1950. So it's not a new area, but they become a breakthrough area only 2010 because of a machine learning program that they use deep learning to predict or identify objects in images, they highlight the previous, they was better than previous models. And today, of course, the deep learning is getting annotation because image recognition, natural language processing, games too, and another areas. I just pass through these terms because it's important for everyone to know what's happening, what are the terms. Actually, I put in these slides detailing each of them, each of the terms, but I won't pass for them today. But if you got the slides copy, you'll be able to see or read the definitions and see the books that I put in the slides. And as I mentioned, there are many terms. So I also put here a video. I really like this video. It's really didactic to explain this, this and other terms as well. Okay, so now I know what artificial intelligence is, what machine learning is, so on. But how can I do an artificial intelligence project? We do have some procedures or steps to develop an artificial intelligence project. One of the most popular procedures, it's called knowledge discovery in database, or KDD. It was proposed by Fayed in 1996, and is this one. But we do have others, okay? So we have Crisp DM, we have Agile AI, but the KDDs is the most traditional way to work with an artificial intelligence problem. So let's take an example. Imagine that I work for a shopping mall. So I am data scientist of a shopping mall. So we do have a lot of data there. So about the companies, the stores, the whatever. I want to detect what is the customers more interesting for my shopping mall. So first step is I have all my data source. I select the target data, the data that I need to do my work. So I selected the let me see, the years old of the customers and how much they spend in my shopping mall, the age and the how much they spend in my shopping mall. So this elaborate my target data. Later, I can do a pre-processing. So I can have some inconsistent data in my data sources. For example, I have some customer that didn't fill the years old field, so I don't know how age what is the years old that they have, so I can remove these customers. I can have inconsistencies in the numbers. For example, I have one customer that spend minus $1,000, so that doesn't make sense. I cannot have a customer that spend a negative value, so I can remove this customer as well. Later, I can do a transformation. So imagine in years old, sometimes it's difficult to work with the absolute value of years old. So Leonardo has 28 years old. Eyal has 35, and so on. So sometimes it's easier to work with ranges. For example, from 20 up to 30, from 21 up to 35, and so on. So I can do this transformation. I can transform the absolute values into ranges. We can also do another kind of transformations. For example, if I work with text, I can transform the text into vectors. If I work with images, I can transform the images into vectors or matrices, whatever. But these are the steps that I have to do to apply a machine learning algorithm. And usually some authors combine these two steps, only calling pre-processing. So selection, pre-procession, data mining, interpretation. So they combine these two steps. But of course, according to FIAD, they are split. But most of the recent researchers used to combine this processing transformation as pre-processing. And later, I do my data mining. How can I do data mining? Usually, data warehouse systems, so SQL, simple SQL, it's a kind of data mining, statistics, or machine learning. In my case, I will apply a machine learning algorithm that is able to grouping customers. So we use to call that as a clustering. So we cluster groups into different groups. And later, I do my interpretation. In this step, I can evaluate, I can apply some metrics. We have mathematical ways to evaluate how good was my grouping, and the business interpretation as well. So, for example, we found that the people who most spend money in my shopping mall is the youngest people, so the younger people. So what I can do with that information? I can hire my store more stores that sells young content, for example, young shirts or young clothes and so on. So we can change my shopping mall according to this information that I got to this machine learning, this artificial intelligence uh, product. And this is cyclical. So, for example, after doing a interpretation, I can come back and try another data mining algorithm, try another technique. I can try another transformation. I can come back and try another preprocessing, and so on. I can do this multiple times. Okay. If you have any questions, please. I will try to answer them during the presentation. I like that format. Okay, so as I mentioned, all data, at least data mining projects, start with data. So we need data sets to work with. Where I can find data? We have some data repositories. We have the most traditional and maybe the oldest repository of machine learning, that is the UCI. It's a university in the United States, I guess. UCI machine learning repository. It contains a lot of traditional data sets. We have today the most popular repository that is called Kaggle. It's not only data set, you can find code there as well. But it is an amazing place to work with different data scientists, like many. uh, and we can find the data sets in GitHub as well and another place. But where can I find a data set of games or a games data set? In multiple places, but we don't have a unique repository for that. So regarding this problem, I create a list called Awesome Game Datasets that contains over 150 contents about games. I mean contents because of course, most of the contents are game datasets, but I also put there open source games, books about artificial intelligence and about games. So and both. What else? We can see APIs. So application APIs, application interface yeah, it's application program interface. So we have some games that have APIs to retrieve data. So we have a lot of content there. It's a really nice place to start to explore and get your ideas. And just to say what is main Oh, thanks. uh, why it's called awesome? Because it's an awesome manifest that is regarding about find the awesome stuff is every day. So exists a lot of awesome lists around the world. We have awesome Python, we have awesome Java, awesome data sets, awesome game data sets, awesome game, and so on. But you can reach the links of these awesome stuffs. Okay, and today I will specifically talk about one game that is the Super Mario Maker game. This was my master research, so if you are interested in do academic stuffs as master degrees or PhD, you can you can work with cool stuffs like games. So you can do research with games. That's important to say because most of my friends or research fellows doesn't believe that I worked with games, and you can do research with games. It's important to highlight that because at least for me, it's not a surprise, but it was a motivation, an extra motivation to work with artificial intelligence. Of course, I like artificial intelligence, but I also like games. So work with two together, it's it's more cool. For who don't know, Super Mario Maker, it's a game that was released on September 25, 15, sorry, 2015, by Nintendo. It contains games from Super Mario Bros. Series. So the Super Mario Maker contain games inside of, or mini games inside of. This game called Super Mario Maker was developed for a specific video game console. It was Nintendo Wii U. And in this game, I'll stop. I stop talking about game. I'll call it platform. Super Mario Maker, it's a platform because it has games inside of that. And in this platform, the player can create a game level, can create, or I used to say game level, course, map interchangeably. So you can create a map where other people can play. You can play maps created by other people. You can, of course, finish or clear the maps. You can like, you can reshare. So the Super Mario Make platform is a kind of social network where people can create a post, like that post, reshare, comment. In this case, you can create a game, play, like, and so on. Uh, just to know how the size, what is the size of the Super Mario Maker. According to Nintendo, if you played every level in Super Mario Maker for 1 minute each, it will take you nearly 14 years to play them all. So it has a lot of games, game levels that was developed by the players. So it's insane the amount of the games that you can play inside of this platform, the Super Mario Maker. Just to show the kind of games that you can develop, actually there are 4 styles, so 4 Mario styles. So it has Super Mario Bros, Super Mario Bros 3, Super Mario World, and Super Mario Bros U, um, where you can play one or all of them in the Super Mario Maker, and you can create a game level or a map using any of these Mario. And each Mario, of course, they are pretty similar. All of them are Super Mario Bros. But they have unique elements or unique behaviors or unique content for each version that you choose. So, for example, in Super Mario Bros. 3, you have this tail, the Mario with tail. In Super Mario World, you have a Mario with cape, and so on. They are different in each other, but the essence are the same. All of them are Super Mario Bros. But the play it's pretty different. The mechanism, the play mechanism are it's pretty different between them. So you can actually create 4 different games inside of the data, say Super Mario Maker platform, using the same elements. So you can use the same elements. It, they are they will be different because of the game mechanisms. Okay, so let's talk about the data set. So during my master degrees, I crawled the Super Mario Maker website and elaborate a data set. So this data set is available on Kaggle, and it contains over 150K game levels, over 808K players, so almost 1 million players, and around 7 millions of interactions. I mean by interaction, it is create a game or like a play a game or play a game. So every action that a player takes, it's an interaction with a game level. Sorry. Um, just to highlight, we have 4 different game difficulties. We have easy games, normal, expert, and super expert games. We have 4 game styles from the Super Mario Bros. Series, so Super Mario Bros. 3, World, U, and so on. And I focus on players from specific nationalities. So the creators, I mean by creators, the players who create games, not who play. Who played, it's from around the world, but who create the gamers are from four specific countries. So they are from Brazil, Canada, France, and Germany. So I cannot collect from United States. The most popular countries was United States and Japan. Japan is the first one, but there are a lot of players, and my crawler wasn't able to collect all of them. So to not collect random samples, I focus on the next countries that was Germany and French and Canada that my crawler was able to collect all of them. Of course, I just chosen Brazil because I am Brazilian, and I like it to. Uh, I thought that I would do some Brazilian analysis, but I didn't, unfortunately. uh, but that's it. I collected information by quasi 5 months. So I run my crawler during 5 months, all day, all night, by 5 months, collecting informations for every game level that was created. So if a Brazilian create a game level, I collect it it is stored in my data set. So if a Canadian create a game level, I will have that information. And I have the changes during these 5 months. So if a Brazilian create a game level today, and I have the likes over the time, I have who played that game level over the time. So it's pretty interesting because you can work with statistical information, so the last state of the data set, or you can think as a dynamic data set that evolves over the time because we have the timestamp in each room. So you have the information of this game level today in the after I collect the information every 2 hours, I guess. So I have the information today and after 2 hours, after 4 hours, and so on. And I also have a paper, so it's right in English, so you can you can read also. Um, and this is the paper about the data set. Okay, so now we know that it's important to work with games because it involves a lot of money and it's cool. We know what is artificial intelligence is and how you can develop a project. We do have data, so we have a data set that is the Super Mario Make data set. And how can I develop my project on top of that? So usually what I do to develop an artificial intelligence project, I think as a PGCA cycle. This is a procedure or a methodology proposed by Swedhart. Oh, it's difficult for me to pronounce this name. Sorry about it. For quality control. And for plan, do, check, they mean. When I think by planning, it is what I want to do, what problem I want to solve. That's the first question that we have to answer. The second, the do, execution. How do it? How can I solve the problem that I propose? And the third, evaluation. Did I do it right? I executed that properly? So these are the steps that I have to do to develop an artificial intelligence project. Let's remember what gaming influencers are. Basically, they are the popular players who have a high influence in new trends. So the gaming influencers is the digital influencers for games. Consequently, companies invest in game influencers to endorse its products. So it's important a company that has game shares invest on me because I am digital influencer, and probably you who is watching my video right now, you buy my chair because I'm always saying that is a comfortable chair, it's good for my back and so on. So for companies, any company that's involved electronic device or games as well, it's important to find the game influence to use and then to endorse their products. Because, of course, because the digital influence has direct relevance in viral marketing. So my problem is, what I want to do is, I want to find game influences in Super Mario Maker. That's my problem. How can I do that? The first question is, has anyone done something similar? Probably yes. So if you're looking for digital influencers or for game influencers or for Super Mario Maker, I found some references, and probably and possibly these references help me. You will help to create my how to do. How can I do? I can see what everyone is doing or what has been done, and I can create my next steps. So my question was, how to detect an influencer? So I am not only focused on gaming influence. I am looking for digital influence in any place. What are the influences characteristics? So usually, digital influence publishing many content, so many digital content, blog posts, videos, and so on. They receive a lot of likes, but not only that. The most important thing is the evolution of likes, trend of peaks. What's that? So we can think in the evolution of likes in a chart, time x likes. So I have the number of likes over the time. So the evolution of the likes, the trend of the peaks are this curve here. This is the importance. This is one feature that you possibly say that this guy or this girl, it's an influencer because usually it's digital, his or her digital content receive has a trend of peaks over the time. So if I'm seeing a YouTube video, I can looking for this trend of peaks. If I'm seeing a Reddit forum comment, if it is a digital influencer, you can see the evolution of likes of that Reddit comment, and so on. So I try to use this characteristic in the Super Mario Maker. Okay, but how I can do that? So basically, I saw what the previous reference, the previous works did, and I replicate similar works and try to apply in my problem. I didn't find a lot of things that match with Super Mario Maker, but I do found similar works that or similar techniques that I was able to test in my problem. And after create this baseline that is the standard approaches of your references, creativity. So enjoy, explore your own ideas, do whatever you want to do, because this is your time to to rethink what your reference did. So this is research. You replicate what other do what did, and try to evolve it, try to propose a new thing. That's the time to propose a new thing. But it's important first of all, is important to create the baseline, the most whole solution for a problem. It could be a random solution, it could be a simple machine learning algorithm, but it's important to develop a baseline approach. Because when you try to propose a deep learning fancy algorithm, you compare with the baseline. So you have to propose the baseline first. Not propose, sorry. You have to elaborate the baseline first. And the baseline will be a simple solution or replicate similar works. Okay, and later you can propose your solution. So first, I have the modeling step that is create this evolution of likes for each game level. So for the 808K game levels, I created this modeling, the evolution of likes in this quasi 5 months. I create a future extraction part. So I used formulas from my references and propose new formulas to identify this trend of peaks. So what formulas? A lot of them. I tried a lot of them. Um, for example, this is one evolution of likes. I simply compute the difference between the previous dot. So I call it delta. So this dot T2 minus T1, the T3 minus T2, and so on. And I compute a lot of things on top of that. I got the K, so the three, for example, the three biggest or the greatest deltas. I got the median, the average, the mode, a lot of simple statistical things on top of that. But remember that for me, important thing is notes or identify this trend of peaks. So I just tried a lot of different things to on top of this formula, this simple formula. Just let me clean. I try on top of angles too. So instead of use delta, that is the absolute difference, I use I use angles. So what's the angle between two dots? And I try to use also linear regression, that is a straight line. I create your evolution of likes and simply put a straight line, and I can compute the curvature using the R2, is this one, or coefficient of determination. It's a metric that say how curve is the chart from the line. So I basically try to compute a lot of different statistics from these three techniques, and in the end, I computed around 60 features. So it's a lot of features. I extracted for every game level 60 features. 60, I mean 60. I don't know if my pronunciation it's good enough. But it's a lot of features. It's a lot of features. And okay, I do the modeling part for the games, but how can I identify the players? So I have to do a modeling in the playing player as well. This procedure is called player modeling. So I extract the features from the game levels, and a player is represented by the combination of the characteristics of his or her games. What that means? So I have a lot of players. I have almost 1 million of players in my dataset. Uh, I have player one who developed two games, player two who developed one game. I have a lot of players who develop known game. And but who develop a game, I can extract the features from a game C1 and a game C2, and a player, the characteristics of a player, the features of a player, will be the combination of the characteristics from his games or her games. It doesn't matter how many games it has. And again, here I put another simple statistic. So again, I do the median, mode, average, and so on. I extract a lot of characteristics, and at the end they compose 60 characteristics too. Okay, so now we do have the characteristics of the players. What I only need know who is a digital influencer and who isn't, and train a simple machine learning model or any machine learning model. Oh, oh, I jumped some slides. Sorry. Oh no, I'm right. Sorry about that. I'm confused. I confused myself. Okay. So I already extract the features, and I want to know how good that features are. So I work with um, a detection problem. Oh, where's my pen? I work with detection problem, and in machine learning, a detection problem, it's called classification. So I want to tag the people in my data set. I want to know who is data game influencer and who is not game influencer. So to evaluate this algorithm, any machine learning algorithm that I want to apply, I use a classification metrics for that. So we have a lot of classification metrics. We have accuracy, precision, recall, F1 score, and so on. So I use these metrics to evaluate how much good was my execution. So just to how I split the data set into game influences and into non-game influences. I got the only the Canadian players, only the Canadian players. I sort them in top 100, so I got the top 100 Canadian players, and I label them as a influencer or not, and I found 41 game influencers in this top 100. So I found popular game influencers. If you are Canadian or if you know some Canadian players who play Mario, you may know who is BRKS Edu. So I found some famous YouTubers in this labeling part. and I manually label them. So we you do have 41 game influences and 59 not influencers. Um, and what I did, I simply get the features that I extract from these Canadian players and press through a machine learning algorithm to try to classify if a train test problem is or isn't a Canadian. It is or isn't a game influencer. Just to tell the technique to do this trend in test evaluation, usually we use a technique called keyfold cross validation, and I use this technique called keyfold cross validation to avoid bias in my analysis. I will put here the name just to keyfold fold cross validation because it's important for you guys if you want to see this later. Okay, and what I did, I evaluated 28 different machine learning algorithms, and the best algorithm reached 87% of accuracy and 90% of precision. What that means? So my algorithm was right 87% of the times. So it's a high metric for real world problems. And precision means that every time they found, oh, this is a game influence, it was right 90% of the times. So I won't discuss about the metrics, but it's important to know that at metrics means something that are different. And for each artificial intelligence problem, some metrics will be more important than others. And I also do a generality test. My question was, is an algorithm trained on one country, that is Canadian, capable to infer game influences in another country, French? So I trained the algorithm only in Canadian players and try to test and try to predict the French players. Who is the French uh, digital influences? The answer was yes. It is able to predict with 77 of precision. It's not so high than 9%, but it's interesting. It's interesting to note that the features of a Canadian players are similar of a French players. But of course, if you do have French players, it's interesting for you label them. So redo this manual part. So manual doing label them as a influence and non-influence, and train the whole data set using both Canadian and French because you'll be able to reach a higher precision. But I only do that to see how generic, how it's my features, and it's pretty generic. Reach 7.77%. Okay, uh, the last part is adjust. Is this the best way? Is the best solution ever? I doubt. I really doubt. Uh, Probably I'm missing something. I can create a better feature extraction. I can even try different machine learning algorithms. I've experimented 28, but there are more than 28. There are more than 100 algorithms. So possibly I can find a better solution for my problem. So how can I do that? It's a cycle. Everything is a cycle. So I do my plan, I do my execution, I do my evaluation, and I can do it over and over and over again. So replan, re-execute, re-evaluate. I can change the evaluation metric. I can do different planning. I can do a different execution. I can structure another kind of features, and so on. Improve as much as you can. Just one important note about that. Hi, Leo. I work in a company that are doing data science. How much can I do this cycle thing? Uh, Usually we have a time tracker. So when we are Oracle in a problem, in a business problem, we have some time. For example, I have 1 month to do a POC, a proof of concept. So in this 1 month, I can do this cycle many times. But of course, this is my end time. So after the 1 month, I cannot work in this project anymore. I have to change for another project or so on. So usually, um, of course, you can improve as much as you can. You can go forever with the same problem, and possibly you reach 90% dot 9999% of accuracy and precision and recall and so on. But in the real world, we used to do a time, a limit time interval to work with. We put 1 month, 1 week, or 2 months, or so on. We cannot work forever in our problems. Okay, so conclusions. Um, this work, only these parts that I mentioned for you, produced for me 2 papers in my master degrees. If you want to know more in details the mathematical part or the structure, the pipelines that I develop, you can read these papers later. But for the most important parts is how can I work with artificial intelligence applied to games? I strongly recommend you to use this list as our first step to work with, because at least for me, I'm not a game developer, so I won't develop my own games, but I would like to access some open source games or to only access the data sets. You can find this information here. Um, you can I present a case of study, so a kind of project, a kind of plan that I can do with the Super Mario Maker. Of course, we can do different things in the Super Mario Maker. You can access the code here, but it's important to remember the steps. So planning is important. It's the most it's the most important part. You have to have a well-defined planning. What I want to do. What I want to do. With that in mind, we can reach, we can looking for references. What have been done? What the other researchers or what industrial guys have been done in this area. And this you'll be in some to use in your execution. So this will be the baseline approach for your problem. And later we can try another algorithms, another things, and so on. And at the end, it's important to be able to evaluate how good enough was, how good was my metric, how good was my machine learning detection, and so on. And of course, we can do any parts of that again. We can repeat the remember the KDD, the knowledge discovery database procedure of FIAD. You can do the pre-processing again, the feature extraction. You can try different data mining algorithms and so on. And the end, last, your creativity is the limit. You can do whatever you want. You don't have a limit to work with artificial intelligence. Just last part, we have jobs. So if you would like to work in a global company, please reach out to me. We have a lot of jobs opportunities. and that's it. Thank you so much for your attention. I only here because of you guys, so thank you.
Thank you, Leonardo. Perhaps, do you mind maybe putting the last link or some of the other links in the chat so people can maybe just copy it from there?
I can do that. I can do that. I have a problem because I used to put a lot of links in my presentation, and I never prepare my a link or something to.
Pick the links with the most influence. How about that?
Sure, I like that idea. But okay, do we have
So,
any questions?
So what you do today at work has any resemblance to that? I presume the process is the same, but is any of the information or anything, any characteristic of your work reminds you of what you did with the games?
Interesting question. Actually, I I'm pretty recent in in data science. I only work with data science for two years and a half, something like that. But I guess any problem, it's always new. That's for me. It's the most interesting part to work with artificial intelligence. Any problem is always new. But of course, what I do is I can reuse most of the machine learning algorithms, most of my code that I've been developed, but it's different. It's if I apply the same the same project that I do with the Super Mario Maker in, for example, Facebook or Twitter, whatever, the results will be completely different. But it's one thing that is important, that every time that I create a I work with a new project, of course I will we are learning new things. We are learning new ways to extract features. We are learning new machine learning algorithms. We are learning a new code or a new project. But it is interesting to see that every time that I work with a new artificial intelligence problem, it's a completely new problem. It could be pretty similar, but the solution will be different because it's a different uh, environment that I implicated the problem. So that's, at least for me, it's one thing that me motivate a lot to being artificial intelligence, because that's it. You can work with detection problem in different applications, but the results will be completely different. You have to train different models. So every time you are learning a new thing.
Good. Anybody else has questions? Anybody else wants to come into the stage and ask aloud? Okay.
And
Okay, Manny, let me see if I can get you to the stage.
and if you are shy and don't want to ask publicly, do any questions publicly, you can reach me later on LinkedIn, and I will
So
answer any question that
Manny
I
is
have.
going to join us. Here he is.
Yeah. So, hello. So I was wondering, have you in your research found out the databases game creators use to create their games? You see, your database is about something else, about the game themselves, right? Which may or may not be the same thing. But what do game creators use? What databases they use? And in fact, if they are using, and I'm sure they are, all of them more or less are using data mining, data science, machine learning, deep learning, all of them or some of them in different combinations. For all of that, you need data. So there's two questions: what kind of
Exactly.
database or data sets they are using, and maybe they are using the data that is generated from their games themselves to do more sophisticated things, right? There's multiple questions in one question.
And that's a tough question. Actually, we do have a problem in artificial intelligence that is generate content.
Mhm.
When we have an area in games that is generate content for games using artificial intelligence, we can see a lot of how how is the name? It's roguelike games.
Mhm.
Most of the roguelike games, these are kind of games use artificial intelligence to generate the map or the position of the objects
Mhm.
automatically.
Mhm. Mhm.
And usually, how can we do that? Um, Most of the research that I found try to create a metric, and they are try to optimize this metric in some way. So for who don't know, this is an evolutionary algorithm. So it's a completely different that I what being showed today,
Mhm.
but this is one way to generate game maps. And right now, I guess this is the state of the art. So they trying to use generative models to create maps, and these maps are evaluated or are we are giving a score for a map. So just to try to explain in more simple way. So if
Mhm.
I'm playing chess, I do play chess. So if you like to play chess, so I am playing chess. I create an algorithm to position the pieces of the chess. So I have a score metric that is elo for
Mhm.
chess, and this metric says how much good is this this positioning. So they try to do the same in the games. So
Mhm.
they have a map and they do create its own metrics to score that maps and try to fit the generative algorithm to reach only create maps with high score.
Mhm.
And we can see that in different games.
Mhm.
But we do also have one one research area inside of the creation, the generative content, creation of content, that is how is the name? It's collaborative approach. That I love that approach. So how that works? I'm creating a game. So Leo, it's a game developer.
Mhm.
So I create a game, and the tool that I using proposes for me characteristics that are interesting to put in my game to turn my game better in some
Mhm.
way. So I do found some references doing that with Mario. So they create environment where developers can create game of Mario,
Mhm.
and the 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 algorithm assist the game developer and
Mhm.
proposes, oh,
Mhm.
put a monster here, put another thing here, and so on. And the IA and the game developer can collaboratively create its own game. And how that IA works, basically that IA reads all the Mario Maker's games developed before. So
Mhm.
they
Mhm.
they collect in some way all of the game Mario levels
Mhm.
and use that as a data set to train this AI to
Mhm.
help the game developers.
Mhm.
That's the that's are some topics that I know that has in creation of games.
I see. Okay.
So,
Thank you. Thank you for your answer.
thank you
So
for your question.
just to make sure that I heard correctly or that I understood correctly, you said that evolutionary algorithms are used to create the structure of the game, the map of the game.
Yes, exactly. It's it's really at least for me it's a little complicated because I don't know so much about evolutionary algorithms, but I do know that in general words they are trying to improve some metric or some score that you propose, and these researchers try to propose different metrics to evaluate the game to say how much is good, and the algorithm generative try to fit or try to reach as much as he can in this score to create good, better and better games.
That sounds indeed like something you would do with this kind of algorithm. It's somewhat related, maybe not exactly, but genetic algorithms or evolutionary algorithms can be used for art. They can generate a picture, and then people will say, "I like this picture better," and there will be some maybe formula that generates the picture, and they will tweak different parameters of the formula or use whatever process to generate the picture, but this will be tweaked to so people will like it. Will give it a higher score. So, but this is a little bit creating a game. It's maybe easier to score, or it may be less subjective in a way because you can somehow measure how much people liked it. Okay, I'm asking that because genetic algorithms are something that I'm very interested in. So I guess there are no more questions at this point. Let me just make sure. No, I think that was great. Thank you very much. Thank you everybody that came to see in person, and the rest of you will probably see this online. We're going to have this recording in YouTube in our channel. Thanks again, and good night. Hey, one more thing, actually. If anybody is still interested, you can go back to the table where we sat, and you can continue the conversation for as long as you want. This can stay open all night, as far as I'm concerned.
Thank you.
Thanks again, and see you next time. Bye-bye.
Bye-bye.